Hello all, good afternoon. It's been a long time since we have continued our classes. So in today's classes, we are going to resume with mathematics, AI ATC Junior before. The topic will be of set theory. This is an interesting chapter, guys. It's one of the easiest chapter when you start your 11th standard. Okay, so let us start with the basic concepts. So what's the set? Representing in a group of elements in a set by bonds called a set. Let's say we have a group of elements named like 1, 2, 3. I want to represent in a form of set. We represent like C is equal to curly brackets 1, 2, 3. Simple. For example, we have another set of elements A, B, C. I want to represent this form of a set. I represent it as A, B, C set with says b equal to set a comma b comma c. Okay, I want to represent a set of natural numbers. We know that natural numbers start from 1, 2, 3, etc. infinity. Okay, I want to represent a set. We write like this: n is equal to set 1, 2, 3, etc. Okay, so now let us learn about representation of sets. Okay, I write the heading: representation of sets. Okay. So there are two forms to represent a set. The first one is roster form. This is also called tabular form. Tabular form. For example, we write like this: E is equal to set of even natural numbers 2, 4, 6, etc. Okay. The second one is set builder form. One is roster form. Okay. The second one is set builder form. These are just basics. I'm just going through it. Okay. There's no need of deep explanation for this. Okay. We use for set builder form, we have to use two important variables. This is called is such that. Okay, comma. Okay, okay. It's represent as such that is true. Okay. Also, we use this particular variable. Okay, for all, for each, for every, or we can see say like for each, or we can say like for all. Okay. Then we use comma. Then we use the symbol for saying belongs to. Okay, then we use this symbol for saying not belong. Okay, so these are just some basics to know. Okay, for example, I want to represent this set, this particular set A in set builder form. We write it this: A is equal to x such that x equal to 2n, where n starts from natural numbers. N is equal to 1, 2, 3, 2, etc. So I'm writing, let's say here 3, 6. So 3, 6, we can give like this less than 7. Okay, on write 7, we can say less than 7. Or you can say like x is equal to less than or equal to 7 also. Okay. Such that where what the n belongs to, n belongs to natural numbers. That's it. Okay. So this is a roster form. And this is set vector form. Okay. Let's move on to the next one. Let's do a small question. I didn't have time to place the question, so I will tell the questions already. Okay. Write the solution set of the equation. Solution set of the equation x square plus x minus 2 equal to 0 in roster form. In roster forms. Simple. Let's factorize this: x square plus x minus 2 is equal to 0. We can write like x square plus 2x minus x minus 2 is equal to 0. Because the sum is 1 and the product is equal to minus 2. So the product numbers are like what? 2 and minus 1, right? 2 minus 1, right? So like, so we'll get like x plus 2 into x minus 1 equal to 0. Okay. So we'll get x is equal to 1 comma minus 2. So the solution set will be A is equal to set of 1 comma minus 2. This is nice. 6. Let's just do one more question. Write the set 1 by 2 comma 2 by 3 comma 3 by 4 comma 4 by 5 comma 5 by 6 comma 6/7 in set builder form. Such as the roster form is given, we need to write a set builder form. First, we need to deduce a relationship how these numbers come. So, likewise, x such that x is equal to, if I'm giving n, the denominator is adding n plus 1, right? N by n plus 1, comma, n. Where does n starts? N starts from 1 less than or equal to n less than or equal to 6, comma, where does n starts? In what type of numbers n belongs to? N belongs to natural numbers, not square brackets, curly brackets. Okay. Something. Okay. Now let us discuss the different types of sets. Okay. Types of sets. Okay. The first one is empty set. Empty set. It is also called as null set. It is represented as like this. Can be represented as either like this, for simplicity, everyone represent like this. Fine. Okay. For example, A is equal to set x such that 1 less than x less than 2, comma, x belongs to natural numbers. Here, this A is a null set or empty set, because is there any natural number that exists between 1 and 2? No, right? So, A is a null set or an empty set. Okay. The next set we're going to learn is finite and infinite set. Finite and infinite set. Finite means the elements are countable. Finite means elements are countable. Infinite set. Infinite set means elements are uncountable. Uncountable. Okay. The next one we are going to learn is okay. Let's give an example of infinite set. Okay. A is equal to set x such that x belongs to natural number and x is prime. Okay. Here we know that it will start like from 2, 4, no, 2, 5, 2, 3, 5, etc. Like set of 2, 3, 5, 7, 11, etc. It will keep on going. We are not able to count the elements. So we can say this is an infinite set. Infinite set are normal sets. Example, A equal to set of x such that x belongs to n and x minus 1 into x minus 2 is equal to 0. So this is an finite set. That is, after solving, we'll get x is equal to 1, 2. So we can write A is equal to set of 1, 2. What is it? Which is a finite set. Right. Okay. Let me do one small example. So in this one also can be asked many JE exams or ATC exams. Okay, question. A is equal to set of x such that x belongs to n and x square is equal to 4. They will ask whether it's a finite set or infinite set. Okay, in this case, it's actually a finite set because x square is equal to 4. We know that x can be either -2 or +2. Okay, but here in this case, since it's belonging to natural numbers, A is of course set to. This is a finite set. Also, it has another name just called a singleton set. Since it's having two values, -2 and +2, and we are taking only one value, so it's called a singleton set. Okay, so this is an entrance point, guys, very important. Okay, let's move on to the next one. Okay, the next one we're going to learn is equal sets. Equal sets. For equal sets, there are two conditions. Okay, for a set to be equal, the number of elements should be same. Number of elements should be same. Secondly, the elements should also be same. The elements should also be same. Okay, let's say A is equal to set 0, which means what? It's a null set. Okay. B is equal to set of x such that x is greater than 15 and x is less than 5. In this case, B is also null set. Right? There is no number that's greater than 15 and less than 5. So B is also null set. So we can say that A and B are equal sets. Okay. Let us go to the next topic. It's a simple topic, equal sets. Okay, subset. Subset. Okay. Write this sentence. A is a subset of B if small a is an element of A implies that A, the small a is also an element of B. Okay, let's say with the help of an example. Let's say B is equal to set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's say A is a set of even numbers. A is equal to 2, 4, 6, 8, 10. C is equal to set of 3, 4, 6, and D is equal to set of 1, 7, 10. Okay, here what is B? B is a superset. Okay, this A, this C, and this D are all subsets of B. Okay, note a point. 5 is a subset of all sets. Because in B there is also 5, in A is also 5, in C is there is also 5, D is also there is 5. 5 is a subset of all sets. Equal set. Equal set. It's a subset of itself. Okay. Let us do a small question based on these subsets. Okay. Consider these sets. Five is one set. Second set is A is equal to set 1, 3. Third set is B is equal to set 1, 5, 9. Fourth set is C is equal to set 1, 3, 5, 7, 9. Okay. We have to insert the symbol subset or not a subset in each of the following pair of sets. So the first set is 5 and B. We know that 5 is a subset of all sets, so it's a subset. Okay. Next one, we need to deduce the relationship between A and B. Let's say A and B. A is not a subset of B because 3 is not belonging to B. Okay. Now let's say check A and C. 1 is there, 3 is there. So A is a subset of C. Okay. Now let us check B and C. B and C. 1 is there, 5 is there, 9 is there. So B is a subset of C. Okay. So that's all about subsets. So now let us learn about the next topic, which is called interval as such. Interval as such. Okay. Now first of all, let us learn about open interval. Okay. Open interval. Open interval. We represent open interval as open interval A, comma B using this brackets. For figure, we'll write like this. A, B. Okay. Which means that X belongs to open interval A, comma B. Or we can write it this. A less than X less than. So that's it about open interval. When you solve the chapter called linear, when we call this, you learn in detail. Okay. Now let us learn about closed interval. Closed interval. Okay. For closed interval, we represent like this. Closed interval A comma B. Okay. So that is x belongs to closed interval A comma B. That is A less than or equal to x less than or equal to B. That's the inequality form. Okay. So the figure is not that much important just for understanding. Okay. A, B, since it's closed interval, we have to just shade this. Okay. That is this portion will be solved. That's okay. Now let us learn the next one. Semi-closed, semi-open interval. Semi-closed, semi-open. Semi-closed, semi-open. For that, we are representing like this. Semi-closed, semi-open. Sorry, let's take semi-open. Okay. For that, the figure will be like this. Since A is closed, we have it afterwards. And this will be B. Okay. That is x belongs to semi-closed A comma B. We see like that since semi-closed is first. So the equation form will be like this: A less than or equal to x less than B. So it will be inequality form or equation form. Okay. And last one, we're going to learn this semi-open, semi-closed. Just the reverse digit. Semi-open, semi-closed. Okay. For that, we are representing like this. A comma B like this. Okay. A, B, close. Okay. Semi-open, semi-closed. X belongs to interval A close interval B. Okay. That is A less than x less than or equal to. This will be the inequality. Okay. Let's go to the next topic. The next topic is called power set. Power set. It's the collection of all subsets of a set A is called the power set of A. It is denoted by P of A. Okay. In P of A, every element is a set. Number of P of A is equal to 2 raised to n. Okay. Where let's say A is equal to set 1, 2. Okay. Here, what is n of A? N of A equal to n. That is the number of elements of A. Okay. So here, in this case, what is the power set? N of P of A. What is n of P of A? N of power set of A is equal to 2 square, which is equal to 4. Okay. So we have the number of power set elements as 4. So what will be the elements? That is P of A equal to, that phi is element of 4, right? Phi is one element. And the possibility is 1, 1, 2, and the possibility is 1, and the possibility is 2. You understand? It's like this. Okay. Understand? We want to write the power set of A. If we have to write the collection of all subsets of set A, what is the all possible all subsets? Set 1, 2 is a subset, set 1 is a subset, set 2 is a subset, also 5 is a subset. That's why it's yes, 4 here. Hope you all understood power set. Okay. Now let's go to the next topic. I'm going very fast because we need to finish this chapter since it's a very small chapter. Because after knowing this chapter only, then we can start the chapter relations and functions. Okay. Universal set. Universal set. Universal set is a set of all elements. Like universe, the whole universe. Let's say U is equal to set 1, 2, etc. 1000. Okay. Let A is a set of all the even elements till 1000, and B is the set of all odd elements. Okay. Okay, these all A and B are all subset. That is, subsets of A is a subset of U, B is a subset of U. Any element is a subset of the universal set. That's it. Okay. Now the next thing we are going to learn is about Venn diagram. Okay. Venn diagram. Venn diagram is a pictorial representation of a set. Pictorial representation of a set. Okay. We are drawing like this. The sets are represented by a circle. The universal set is represented by a rectangle. Okay. These are the sets. So this is the universal set. Okay, so when we draw the Venn diagram, it will be like this. Set A, we will draw this A. So elements like 2, 3, 4. Remaining elements like 1, 5, 7. They all will be part of the universal set U. Okay. 7, 9, like that. Okay. So that's a very easy topic. So let us now learn about operations of set. Operations on set. The first one is union of sets. Union of sets. Union of sets we are represented by a small u. Okay, that is A union B, which is also called A or B. Okay, the Venn diagram representation of union of sets will be like this. A, B, both will be shown. Okay, that is A union B. Okay. Example. Question. Let A is equal to set 2, 4, 6, 8 and B is equal to set 6, 8, 10, 12. What we have to find? We have to find A union B. A union B is equal to set 2, 4, 6, 8, 10, 12. Okay. The next one we are going to learn is intersection of set. Intersection of set. Okay, intersections of set, like we are representing as A intersection B, which is called A and. That is, we are only going to take the common elements. Common elements. The Venn diagram will be like this. This is A and this is B. The common elements will be here. Right? That's it. Okay. So based on the above example, based on this example, what is A intersection B? In this example, A intersection B will be the common elements. It will be just 6 and 8, right? Yeah. Okay. If A intersection B is equal to 5, that is a null set, then that set is called disjoint set. Disjoint set. Okay. Okay, now we need to know some properties of operations of intersection. At the heading, some properties of operations on intersection. First one, A intersection B is equal to B intersection A. Okay, this is called commutative law. Commutative law. Second one, A intersection B intersection C is equal to A intersection B intersection C, which is called associative law. Third one, phi intersection A is equal to phi. U intersection A equal to A. That is the law of null set and universal set. It is called law of phi and U. Okay. Fourth one, A intersection A equal to A. This is called what? Idempotential law. Okay. Fifth one, A intersection B union C is equal to A intersection B union A intersection C. This is called distributive law. Okay. Now let us learn about. Please learn these properties. Okay, guys. Pretty useful questions. Now let's learn about difference of set. Difference of set. Let's say let me have question A is equal to set 1, 2, 3, 4, 5, 6. Okay. We have B is equal to 2, 4, 6, 8. Now we have to find the difference of set A minus B. First of all, let me give a definition of A minus B. In order to find A minus B, what we have to remove all common elements of A and B and take remaining element of A. Element of A. If it is B and B minus A, we have to remove all the common elements of B and A, and we have to take the remaining elements of B if it is B minus A. So as per the question, what we have to find? We have to find A minus B. First of all, let us move the common elements. What is the common elements? 2 is common, 4 is common, 6 is common. What is the remaining elements of A? 1, 3, 5 is the remaining elements, right? So if you want to find B minus A, we have to remove like 2, 4, 6, right? Then what are the remaining elements of B? 6. Now let me show a Venn diagram representation of this question. Not this question, difference of set concept. Okay, Venn diagram representation. Okay, A, B. A minus B means only A. That is like this. So this is A minus B. B minus A means only B. Wait, I'll use it. Okay. This is B minus A. Okay. And what is this? What is this? This is A intersection B. Okay. Okay. Now let us learn about complement of a set. Complement of a set. Okay. Let's say we have question U is equal to set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And we have set A is equal to 1, 3, 5, 7, 9. Okay. We have to find complement of set. That is A complement, which means that not A. Not A. That is which means like U minus A, which is equal to A dash or A complement, like this. Okay. Or we can write A complement like this also. Okay. In question, they can ask in different ways. Confuses. Okay. So as per this question, what's the answer? A complement. So here a complement will be not a one not possible, two is possible, three not possible, four possible, five not possible, six possible, seven not possible, eight possible, nine not possible, 10. So this is that. Okay. Now let us show that Venn diagram representation of complement of A. Okay. Let us draw the units research. Yeah. Okay. So this is, we know that what is this? This is A. What is not involved in A, that is A complement. That is okay. This is A. Okay. Now we need to learn about some properties of complement of set. Properties of complement set. Okay. So what is the first property? First property we need to learn about complement laws. Complement laws. That is, first one is A union A dash equal to U. Second one is A intersection A dash is equal to 5. 5. Second one is De Morgan's law. De Morgan's law, the first formula is A union B the whole dash equal to A dash intersection B dash. Second one is A intersection B the whole dash is equal to A dash union B dash. Okay. Third one is law of double complementation. Law of double complementation. Okay. A dash the whole dash is equal to A. Okay. Fourth one, law of empty set and universal set. Law of empty set and universal set. Okay. That is 5 dash is equal to U and U dash is equal to 5. Okay. Fifth one. Seven. Fifth one. N number of A union B is equal to N of A plus N of B minus N of A intersection B. Okay. Also another formula, this is special formula, N of A minus B plus N of B minus A plus N of A intersection B. Special formula. This is special formula. Okay. Let's write one more formula. Sixth one, N of A union B union C equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C plus n of A intersection B intersection C. So there's one more thing, minus n of A intersection C. Okay, write down this formula, guys. Okay, so these are all the concepts for this chapter. Let us do one question and write up the class. And more questions will be discussed in the discussion class. That is the problems, numerical solving. Okay, question. First of all, I'll just read the question and then write the variables for that one. In a school, there are 20 teachers who teach mathematics or physics. Of these, 12 teachers teach mathematics and 4 teach both physics and mathematics. How many teach physics? Okay. You can just listen to the question once more by seeking 10 seconds before. Okay. So what are the variables given here? There are 20 teachers who teach mathematics or physics. I'm going to denote M as mathematics and P as physics. Mathematics or physics means n of number of mathematics or physics is represented as n of M union P, which is given as 20. 12 teach mathematics. N of M is equal to 12. And 4 teach both physics and mathematics. And means M and P means n of M intersection P, which is all given as what? 4, right? What we have to find? We have to find the number of people who teach physics. N of P. Right. So we have a formula, n of M union P is equal to n of M plus n of P minus n of M intersection P, right? So what we have to find? We have to find n of P, right? So 20 is equal to n of M 12 plus, I'm going to n of P as x minus as x minus 4. We'll get x is equal to 12. Okay, x is equal to 12. Directly we can find, or we can find the help of Venn diagram. Sometimes we can, those who are very familiar with Venn diagram can solve it very fast. Okay. As per the question, this is the M and this is P, right? So what is the data given as n of M intersection P? This is given as 4. What is n of M? 12. This much is 12. So what is this much whole n of M? Minus P, 8, right? So what we have to find? We have to find P. Okay. P. We know that total of P is x plus 4. So if this is x, we can't like this. Okay. So this will be, let's say total of P, n of P is equal to x, which means that n of P plus 4 equal to x, right? That's what means like here as per the Venn diagram. So what will be this? X minus 4. So as per the question, n of M union P is equal to 20. So we can write that 8 plus 4 plus x minus 4 equal to 20. From that x will be plus. So those who don't understand this thing can use this formula, basic formula, or they can use the Venn diagram. Okay, Venn diagram is most useful. Okay, so at an entrance point, this can be asked in ATC exam. Okay. Number of proper subsets. Let's say we have A is equal to Z1 to Z1 to 1 to. Okay. Let's say we have n of A is equal to M. Then we have to find the number of proper subset. Number of proper subset equal to 2 raised to M minus 1. Okay. This is an important thing, guys. So this is all for the chapter set theory. I have explained the important formulas along with some questions. as well. So we will be discussing more questions in the discussion class, which is part two. So everyone, please go through these concepts before attending the discussion class, guys. So hope all of you understood. And many people were asking about the vacancy. Vacancy will be released soon as per the notification as per AIA. So what I can say is that I will try to finish the portions before the recruitment notices are made, so that when after the recruitment notice will be solved by marathons of questions. Okay, from many textbooks, from many previous year questions. And I'm also releasing YouTube shorts daily, which is discussing previous year questions for both physics and mathematics, and also English vocabulary. English vocabulary. So this is the only YouTube channel which you get English classes for ATC in free. That is all the contents, physics, maths, aptitude reasoning will be explained in English. No other channel will give that for free. So please subscribe this channel and for click on the bell icon for more videos. I'll be releasing more videos soon. So thank you all for attending the class. Bye.